Okay, we'll go to engine performance check. You see the auto cycle. Last time I did ask you about thermodynamic cycle, and most of you didn't answer my question. What is the ideal cycle of thermodynamic cycle? Never mind, you can put that into the midterm test or anything else. Okay, auto cycle was first demonstrated in 1876. It is known as 4-stroke engine. This is probably the most common engine types at the moment nowadays, and the 4 strokes of the cycle are intake, compression, power, and also exhaust cycle stroke. Intake stroke, compression stroke, power, and exhaust stroke. Each correspond to one full stroke of the piston, and therefore the complete cycle requires 2 revolutions of crankshaft to complete. So crankshaft moving 2 rotation or 2 revolution, this is one complete cycle. Okay, we can see the graph in the thermo or the auto cycle. It's actually one from here, 1 to 2 is the isentropic compression, 2 to 3 is the constant volume, the volume is not changing, and 3 to 4 is the isentropic expansion, and 4 to 5 here is the constant volume heat rejection, and 5 to 6 will be known as exhaust at ambient pressure, and it's actually go back to 6 to 1 where it will be the intake stroke. Okay, you see detail during the intake stroke is 6 from 1. The piston move downwards and the draw combustible mixture and fuel air past the throttle and the intake valve into the cylinder. At this stroke, the intake valve open and the exhaust valve close. The intake valve is open, exhaust valve is closing, and this is intake stroke. Constant pressure intake of air at intake stroke. Second one, from 1 to 2 is the compression stroke. During the compression stroke, piston was moved upwards, going upwards, this piston, to compress the fuel air mixture. All the valve is closing, all the valve here is closing, and it will raise the temperature of the mixture, and at the end of the stroke, a spark ignites the mixture towards the end of the compression stroke. After this, will start compress ignition, and then when ignition start, this is the power stroke, 2 to 3. The spark plug fires, igniting the compressed fuel, and as a burn, and the fuel burns, driving the piston downwards, piston going downwards after that, and the fuel air mixture. At this stroke, both intake and exhaust valve is closed. Both of the valve is closed, but the piston is going down. And then it goes to compression power or compression stroke, expansion stroke, where after the combustion from 2 to 3, the constant volume heat input, and then where the power stroke again, the piston is going down, so the volume is becoming low, increase, volume is becoming higher and higher. And after the power stroke, from 4 to 1 is at the bottom of power stroke, the exhaust valve is open, by the cam mechanism. So the exhaust is open, and the upward stroke of the piston drive the exhaust fuel out of the cylinder. So exhaust going out from the cylinder, and at this stroke the intake valve closed and the exhaust valve is open. So when the exhaust valve is open, the volume is becoming lower and lower and inside the combustion chamber, and this process for exhaust go down, and after this constant pressure exhaust stroke. Okay, for this thermal efficiency of the Otto cycle can be calculated with both of this equation 2.29, and by using the isentropic expansion and compression equation we can create the thermal efficiency of the Otto cycle for the 2.30 or 2.31. And if we actually see the actual 4-stroke spark ignition, the thermal Otto cycle will be like this, and this is the actual one, where they also have the ideal cycle, and be the bottom graph. This is actual and ideal cycle in the spark ignition engine and their PV diagram, pressure versus volume diagram. Okay, this is ideal Otto and this is the actual one.